So we are in section 1.1, Nets and Drawings for Visualizing Geometry. Let's look at this a little bit on page 4. Let's try to see what this lesson's about. So, when you shine a flashing light on an object, you can see a shadow on the opposite wall. What shape would you expect the shadows in the diagram to have? Explain your reasoning. So, the flashlight is projected on this 3D object, and they want to know what kind of shapes are the shadows going to be. So what kind of shapes do we have here and here? So as you think about that as we're going through the 4 problems in this section. Alright, so problem 1. The net at the right folds into a cube shown beside it. Which letters will be on the top and front of the cube? Alright, so we already know that C is going to be the front because that's where everything's going to be folding around it. So you see A, C, E, and F all fall and share an edge with the D. When you fold the net, but only 2 of the sides are visible in the cube shown. So as you look through your notes, you know that a net is a two-dimensional diagram that you can fold into a 3D dimensional figure. So from 2D to 3D. So as you wrap this around, and this is being folded outwards, as you wrap it around, you see that C is going to be the center, and E is going to be on top. So it's hard for me to draw it for you. I need to show it to you on here. So when you fold everything on the outside, the front will be C, which is the center of the cube, what we're looking at now, and E is going to be the top. So why don't you try to got it? So suppose that B is in the front. What's this question mark? And what's going to be on the top and what's going to be on the right of the cube? So you're using the same cube as the one right here. Let's look at problem 2. What is the net for the graham cracker box to the right? Label the net with its dimensions. So this is the graham cracker box we're looking at. And the net is, we're going to unfold it into a 3D. So you can see us folding step 1, then 2, 3, and then finally it's unfolded. So you see here that, let us put it up here. So as you can see here, this is the length, the width, and the depth. So these are the dimensions when you unfold and look at the net of a box. So we went from a two-dimensional diagram to a 3D figure. Alright, so why don't you try to got it letter A? What is the net figure for the figure at the right? Label the net with its dimensions. So, again, you're going to unfold it and look at the dimensions. Alright, problem 3. This is where it gets a little tricky because I do not have isometric paper. Isometric paper you should see in your student companion book. So let's see if you have it. Alright, you do have it, so good. Alright, so isometric is a drawing, it's a corner view of a 3-dimensional figure. So I'm kind of drawing like a rough sketch. So what is an isometric drawing of the structure at the right? So you can see that I drew the structure. So how it is on the right is, let me try to use this dot paper. So I'm going to draw the front first, which is kind of like an L. So I'm going to connect these 3 dots. It's going to go down 1. It's going to be 3 total here. So this is the front. So you can see that I got the front part there. So the top part, let me get here. Should connect here, here, and there. Alright, and then when I'm done connecting everything, let's be a little neater with this. So you can see that's the part I just drew right here, 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 and here. So this is the front, and this is the right side of the view. So let me draw it down here so you can see it. So I first drew the L, which was the front. Then I drew the sides of the cubes. Then I connected the lines so you can see a 3D drawing. Alright, so why don't you try the got it? What is an isometric drawing of the structure now? Because Ms. Chen is not an artist, you can see it more clearly on page 4 in your student companion book. It is number 25 and 26. Alright, so problem 4. This is where my drawings are not very good. Okay, so we want to know what an orthographic drawing of an isometric drawing. So orthographic is a top view, front view, and right side view. It's another way to represent this 3D model. So if you were to flip this shape, like visualize 3D, this is what the top would look like. You could see this is the right side of, this is this part, and then the second part is just the top of the cube. So this is the top. So let's try the front view now. The front view, you can see we see this rectangle. So I'm going to draw this rectangle. Oops. And then you're going to see this is supposed to be a cube right there. So I'm going to draw a cube. And you can see this is the other side. So let's draw that. And since these two squares right here, they're not connected, this is going to be a dotted line. So, Alright. And so the last view is the right. So you see from the right view that you have this long rectangle right here. The long rectangle. And you have the two squares, one right here, and there's one, just a square right here. So then, the two squares. That's your orthographic. So, try the got it on page 5, number 27 and 28.